am Tangashakti from EEE Department, Rohini College of Engineering and Technology. Subject name EE8591 Digital Signal Processing. In this video, we are going to see IAR filter design with impulse invariant transformation. So from this session, you can understand the design of IAR filters with impulse invariant transformation. So first you should know the objective of impulse invariant transformation. So is to develop an IAR filter transfer function whose impulse response is the sampled version of the impulse response of the analog filter. In short, we can tell with the help of impulse invariant transformation, we can convert the transfer function of analog filter into the digital filter. It can be stated that the frequency response of the digital filter will be identical with the frequency response of the corresponding analog filter if the sampling time period is selected sufficiently small to minimize the effect of aliasing. Let us consider here h of t is the impulse response of the analog filter. So next we have to take the transfer function of the analog filter. So h of s equal to Laplace transform of h of t. So we can write h of s equal to sigma I equal to 1 to n ai divided by s plus pi. Next we can write like this. Here h of n is the impulse response of the digital filter. H of t is the impulse response of the analog filter, and h of n is the impulse response of the digital filter. So the impulse response of the digital filter is obtained by uniformly sampling the impulse response of the analog filter. So here h of n equal to h of t at t equal to nt. By sampling the impulse response of the analog filter, we can get the impulse response of the digital filter. Okay. So here we can get h of n equal to h of t at t equal to nt. So we can write h of nt equal to sigma I equal to 1 to n ai e power minus p I n t u of nt. On expanding this, we can get a1 e power minus p1 nt u of nt plus up to a1 e power minus pn nt into u of nt. Next we are going to take the is the transform of the equation. So we will get a1 into 1 by 1 minus e power minus p1 tz power minus 1 up to an 1 divided by 1 minus e power minus p n t z power minus 1. On comparing the equation of h of s and h of z, we have one relation, that is 1 by s plus pi is transformed. It will changes to 1 by 1 minus e power minus pi t z power minus 1. So this is the impulse transformation equation. So the 1 by s plus pi is transformed to 1 divided by 1 minus e power minus pi t z power minus 1. So here t is the sampling period. Next we are going to see the relation between analog and digital filter poles. So the analog poles are given by the roots of the term s plus pi. So for here I value changes from 1 to n. So the digital poles are given by the roots of the term 1 minus e power minus pi t z power minus 1. Here the values I changes from 1 to n. Now the analog poles at s equal to minus pi is transformed into the digital pole at z equal to e power minus pi t. So here we can conclude the following observations. If the analog pole Si lie on the left half of S plane, the corresponding digital pole Zi lie inside the unit circle in Z plane. if the analog pole lies on the left half of S plane means the corresponding digital pole will lie inside the unit circle. And next one, if the analog pole Si lie on the imaginary axis of the S plane means the corresponding digital pole lie on the unit circle in Z plane. Third one, if the analog pole is lie on the right half of S plane means the corresponding digital pole will lie outside the unit circle in the Z plane. Okay. So here we can see the diagram. So here this is the imaginary, this is the S plane and it is the Z plane. So here in x-axis we are taking sigma and y-axis we are writing j omega. So here the left half of S plane is transformed inside the unit circle in the Z plane. And the right half of S plane is transformed to the outside of the unit circle in Z plane. Okay, thank you.